Hey guys, and welcome to Functional Print Friday, and welcome back to my shop. So on the workbench this week I have what I believe is going to be the units I need to build a wireless bridge between my shop here down by the house and the barn up in the backyard. And the reason these are on the workbench this week is because I want to come up with a mounting system for these. So these can be mounted either on a pole, see they actually have like a curved back here, or just on two screws. So we're not going to mount these on a pole. I don't think we need to. Each building has a face that more or less points in the right direction. Although I do actually want to measure that. That may be part of the other reason to have mounts here, because I would like to have these as part of the mounting system pointed in the right direction. But the other thing is I don't like this method of having two screw holes here to mount them. I'm not a fan of this, particularly on the barn side. I don't think we're really going to have the control over the mounting screws that we need to sort of turn them in and out to get just that right tension as we pull them up onto the upper part here. And even if we did, I don't think that tension would stay, because on the barn side, these are just going to be mounted into metal siding. So I'd like to come up with a mount that basically fits between this face of the back and whatever we're actually mounting to. I think we'll probably still use these holes. Like maybe we just design like pins into our mount that this will go on and then slide into place. I'd like to have it lock in place too. It's going to be tough to reach around here and have any type of like a screw or something like that. So maybe we integrate like a lock into the side, or maybe like a click lock into the top or the bottom. I've got to think that through. Oh, and I do want to quickly mention, this video is not sponsored or anything. I paid for these. These are from Amazon. I picked these because it was a combination of it was cheap and it looked like it was going to do the job. So if this does end up working, I will put a link down in the description of the video, but I'm hoping by the end of this video we actually are able to test these. It's not super far from my shop here down by the house up to the barn. It's about maybe 300 feet, somewhere around there. So I think the range on these is supposed to be like 3 kilometers, if I recall. Yeah, transmission distance can reach up to 3 kilometers, so that sounds pretty optimistic. It's probably not really going to work at 3 kilometers, but I think 300 feet should be no problem at all. So yeah, stay tuned to the end if you want to see if these things actually work. All right, I'm going to get those measurements and I will bring you guys back when I have something to show you. All right, and here is the initial design that I came up with for this. And I basically modeled it to match the back of the device itself. I just walked around my shop till I found something that was pretty much the same curvature as the back of the device. I think it was a roll of tape. And I just measured the diameter of that. So that's probably not perfect, but I think it's going to be close enough for this. And the pins, I tried to just make them a nice tight fit. I modeled it exactly to the same dimension. So the distance between this face and this face here as the thickness of those wings that come off the sides. That should be a nice snug fit. And I know what you're thinking. You're thinking, yeah, those pins are just going to break off. And if we printed it with this down on the bed, I think you're right. But I'm not going to do that. I'm going to print it with this face down on the bed, because that's going to give us better geometry up here anyway for this part that I modeled that is hopefully going to click lock this in place. My idea is, you know, we bring the device, so we mount this on the wall. We bring the device up and push it against this face, which is going to depress this back, and then slide it down. These slide into the smaller channels on the back, and then this clicks in place and holds it. And we can reach around either with a finger or like a screwdriver, push this back and slide it back off if we want to. That did mean that I needed to lower the mounting hole here on this base part. I originally had this up higher, and then when I added the geometry for this piece to push back, I had to bring that down. I think we'll still be okay there, but this is one of those where I think I'm probably just not really going to be able to tell until I actually print this out and I'm holding it in my hand. So let's do that. I don't want to go any further on this because I don't know how well this initial design is going to work and how close we are on all these things lining up. So let's print this out and I'll bring it back. All right, our first test print is done, but I didn't turn supports on, and I should have. I kind of figured for a test this wouldn't really matter if we had a hard edge up here, but it was really bad and I made a bigger mess of it trying to clean it up. So let's see if this works. So this is super stiff. It's not breaking though. I guess, so So to emulate how this is going to be, like this would be secured to the side of the house or the barn. So I'd be pushing on that. Okay. Yeah, it doesn't really lock. I think that's because we just don't have a hard edge up here. And I can see these sort of wings here, if you will, on the side bending inward. So I don't think we're quite right on that measurement, but it does fit. So I think that's not bad from a V1. I think our screw holes are probably deeper than they need to be. I might come back up on those a little bit more. Yeah, I was just trying to make sure that our screw head was completely clear of that curved front face, but I think I overdid it. So we can probably change that. And, you know, looking at this, I don't know why I made it the exact same size and shape as the back of this. It doesn't need to be. You know, I guess I was thinking I wanted to keep it streamlined. I didn't want to have this gigantic mount back here, but I think this is too small. So I think I may also maybe give it a flatter face on the back, because this, like, there's going to be some force from the wind with this guy rocking back and forth, and right now we're only distributing that force onto these tiny wings here on the side. So I think what I'm going to do is increase the size of this. Maybe we'll come out like another 50, 70 millimeters on each side, just to give it more surface area so that it's not wrenching back and forth like this. Let me think about it. I'm going to do that, and I'll bring you guys back when I have a revised design. All right, our V2 is done, but I've already broken it. I thinned this out too much here at the top. I think the other changes I made on here are good. I sloped the top downward a bit, so if water collects on the top, it drains off. I raised up the bottoms of our counterbores here for our screws. I put sort of curved wings on the sides. I'm happy now with the amount of surface area here on the back. But yeah, I thinned that out too much. And you know, this is printed in PLA. PETG would probably be a better choice for this. I think it would give us a little bit more flexibility. So I might change that up. You know, another option is I actually did get some of the TPU for AMS, and I haven't used it yet. There's actually a roll of it in the filament dryer. It should be ready by tomorrow. Maybe I'll revise the design to have just this part print in TPU. And that might not be a bad idea, because we don't need, I could print the whole thing in TPU, but I think that would be a waste and it's going to take longer. But yeah, what if we just printed just like this push tab up here in TPU and left the rest as PLA or PETG? Let's see if this fits. Yeah, it actually fits really well. I also put the model number here on the bottom. I don't think I'm going to keep that. I'm not sure. In my head, I was thinking, it'd be nice to look up and see what these are without actually removing them, but they're so easy to remove. There's just no point in waiting the extra time for the color change. And I see somehow, probably when I was sloping the top, I ended up coming up too far here on this face, because we're coming up past, if you guys can see that. Like this should be, it should be flush. Like that. All right, I'm going to go remodel this to have this top part done in TPU, and I'm going to figure out the angles that we need, because the other point of having a flat base on the back here is that we can actually tip this to the right angle so that they are pointed at each other. I think if I recall, the antennas are like 60 degrees included angle, which should actually hit both buildings, but I think when the tree coverage comes in, the more that we can do to point these directly at each other, I think is going to maximize the signal that we have. So, all right, I'm going to go do that. Once I have the designs of both of those figured out, I'll bring you guys back. All right, while we're calculating the angle that we need to adjust the back to, I went ahead and I just quickly modeled this up to be printed in the TPU for AMS instead of just all one material. And all I really did was just thicken this up just a little bit, and I pushed these faces all back by 0.05 millimeters just so that I can easily, in the slicer using the paint tool, change the material. That is, by the way, that is the quickest way if you want to use a second material or make anything another color, is if the face itself is a slightly different height. It doesn't even have to be enough that it's actually going to make a geometric difference in the face of the design, but just if the slicer interprets the face as a different face, it makes it really, really stupid simple to go in there and just click on those faces and set them to another material. So I'll go into the slicer and I'll just click on each one of the faces of this part, and probably this base down here as well, and just set those to be the TPU for AMS. and then I'll get this printing while we figure out the angles. All right, that test one that I kicked off while we were figuring out the angles is done, but I made the mistake of messing with it before I turned the camera on. I gotta stop doing that. Yeah, this TPU for AMS, I don't know if it's a fluke, if it was just the beginning of the roll or what. I mean, I did leave this pretty thin. I expected this stuff to behave like normal TPU, and it clearly doesn't. And I did a little bit of Googling on it, and yeah, a lot of people are saying the same thing. I am not impressed with this material so far. I barely pushed on this. In fact, I think I actually heard it crack just pulling the supports off of this piece. And then as soon as I pushed it at all, it just cracked. And it did actually, this was stuck really well. The interface between the TPU and the PLA, I pushed on this really hard to break that loose. I just wanted to see how much force it would take to do it. But this, I bet you I could break even just this little piece. Yeah, easily. It's, let's see if I can break it in this direction. In Z, it's terrible. I mean, the layer adhesion just seems really, really bad. Yeah, I mean, it's actually not very flexible in this direction. I'm not sure I understand what this material is for. I'm gonna thicken this back up when I print the final ones. I know what angles I need to adjust the back to now. So I'm gonna do that, and I'm gonna thicken this way up and see if we just give it more surface area. Because, I mean, to be fair, this does not have a lot of surface area. That's like, even though I had the walls set to 2 walls, it's probably only fitting 1.5 walls there. So there's not a lot of surface area, but I mean, if we had printed this in normal TPU, there's no way I could have, even with a print this small, there's no way I could have pulled that apart. Normal TPU is incredibly strong. So yeah, I don't know, swing and a miss so far on this. But I'm gonna go ahead and print out the final ones with the correct angles on the back, and we'll see if a thicker top section does better. All right, so here is my idea for calculating the angles, and I've pretty much done all the work here already. I just went into Google Maps and I brought up my property, and here's the 2 buildings in question. And I looked at the approximate positions that I intend on actually putting these wireless bridge devices. And these, I know there's a lot of lines here on your screen, but the dashed line coming off of here and the dashed line coming off of here represent a 60-degree included angle for perpendicular to the face that we'd mount to. And it looks like if we just had them coming straight off the back, we're still within that 60-degree cone. But I think the signal is going to be better the closer we are to the center of that 60-degree cone. I'm not 100% sure on that. That is my guess. So I want to adjust the angle to be the closest to the center of that cone as we can get it. And the barn's the same way. Here is that 60-degree included angle cone coming off the back of the barn. And again, the garage is within that cone. But we can use the angle tool here to just come in and measure this. So if this is the point roughly where that's going to mount, if we come off perpendicular to the building, and I had another line in here actually to get it exactly perfect, but I'll just guess there. And then we come back to our line here, which is just a straight line between those 2 points. Yeah, this measures 11.4 degrees. I think I had 11 before. So we'll do 11 degrees on that one. And I just did the exact same thing up here. If I came off perpendicular to the building and then adjusted it to our direct line of sight, and it was about 5 degrees. So I'm gonna do that one as 5 degrees. And yeah, they're probably not gonna be perfect, but it is going to be better than just flat mounting them to the back of these structures and just, you know, crossing our fingers that we are within that cone. I think we'll probably be within, I don't know, let's say it's a 2-degree margin of error, which is a lot better than the 5 degrees and 11 degrees that these would have originally been. So, all right, let me go adjust the back of 2 of those and I'll bring you back. All right, so here is what is hopefully our final design. I've gone ahead and thickened up this top section here for the TPU for AMS, and I actually brought this face back forward here a bit as well to limit our ability to bend this guy back into that face so that we, you know, basically we can't overbend it. And I'm hoping that that's going to be enough to give us better adhesion between those layers for this guy to hold up. And we'll use the same method. This face sits back just a tiny bit from the rest of the faces so that I can basically paint all of these into being TPU instead of the PLA like the rest of the print. The one for the barn is 5 degrees, and you can see I've modeled in the profile of the siding on the barn as well, because this one's going to be secured tight to the barn. There's no, I don't need any wiggle room at all behind this, and otherwise there'd be a gap here if I didn't have this modeled in, and we'd be sort of pulling the sheet metal up to the flat back of this. This way, the wings will contact against the the ridges in the siding, and this flat face will go right against the flat face of the metal siding on the barn. The one for the back of my shop is at 11 degrees, and this is just a flat face. This is going to go on vinyl siding. The vinyl siding is going to be, I should say this is going to be taller than one section of the vinyl siding. I thought about modeling this to follow the profile of the vinyl siding. I don't think it's worth it. We can't snug this up against the vinyl siding anyway. Whenever you're securing anything to vinyl siding, you do not want to tighten it up against the siding. So you'll probably see me snug these screws up and then back them off a little bit and get them to where it's just barely pulling this face into the siding, because vinyl siding on a structure is going to shift around. It's going to expand and contract as the temperature changes. So you do not want to make that tight. So yeah, I think we're just going to leave this one as a flat face, but we do have the angle set to hopefully point directly at the unit on the barn. So, all right, I'm going to print both of these out and cross my fingers that everything is good. All right, both of these are done, and I didn't make the mistake of messing with these before turning on the camera this time. I even left the supports on, because at this point, if these break, I'm willing to call this TPU for AMS an absolute waste of time and money, because I mean, the PLA one, which is a fairly stiff, not brittle material, but it's going to break sooner than like PETG, that didn't break. So let's see what these do. I will say that the TPU seems to adhere to the PLA really well. This is just like the interface layer up here. I'm just being nitpicky. All right, moment of truth. Let's see if I can push this for it to clear and it not snap. Nope. Yeah, this, that's all right. I may end up redoing these in the future to maybe have that as a separate piece and do it in regular TPU. I'm really disappointed in this material. I'm not saying it doesn't have an application. I think if you were to integrate like rubber feet into a design directly, or maybe have like a sealing surface or something like that. I even upped the temperature on this to 245 degrees at a recommendation that I saw in the Bamboo Lab subreddit. The layer adhesion on this stuff in the Z direction it's just terrible. It's the worst of any filament I've ever used. It sticks to PLA just fine. Like I'm pushing on that just about as hard as I can, and I cannot break the base loose from where it attaches to the PLA, but yeah, it does not stick to itself very well. Let's try this one. Okay. I mean, for whatever reason, this one, nope, never mind. Yeah, it's terrible. All right, well, we're losing daylight. Let's put these up anyway. I can always come back and put a revised design in place. This will also confirm that we have the angles right, and I did shape this one to follow the contours of the metal siding on the barn as well. So at least we'll find out if all that stuff fits, and we can come back and replace these with a better design for that tab at the top. I am, again, really disappointed in the TPU. I think I may just redo this with a two-part design, like a TPU piece that clicks into the top that's just plain old regular TPU. Regular TPU is like indestructible in even the Z direction. So, all right, enough talking about it. Let's put these up. All right, well, you can see we're losing light, so I'm going to be brief, but I think this went well. It was actually really nice having that key into the metal siding, because I didn't have to try and figure out where level was. It only keys in one way. So I will have to come back up here and silicone where this comes through and shorten up this loop, but I think that should do us for now. And you can see my shop. That is the building down there on the left in the distance. So let's go put that side on before we completely lose the light. All right, barn is up there now, and we do not need a ladder on this end because I've got this little tiny balcony off the back of the garage barn/shop. And this one is going to mount up here. And I've already pre-run the wire. And yeah, I totally need to pressure wash this siding back here. This side of this building gets zero sun. So it just, I guess it maybe just stays damp. This is the only place on the house or the garage that we get this this like kind of, I guess it's algae that grows on here. Comment below if there's anything you've actually sprayed onto your vinyl siding that has prevented this. The only thing that I've found so far is just coming out and pressure washing it every 2-3 years. So all right, I'm gonna see if I can get the camera set up in a spot that you guys can see. I wanna get this up pretty high. If you look, the algae line is kind of like there, and then there really isn't much above it. So I'm guessing it probably stays dry up there from the little overhang of the roof. So I wanna try and get it kind of up here. All right, that'll be good enough for now. I'm gonna have to come back and shorten up this wire so that I have just kind of enough to make a loop and an S to come up. So I have a drip loop on here and tuck into the J channel, but that'll be good enough for testing this. Let's go back up to the barn. All right, we're back here in the barn. I just got to spend 30 minutes walking back and forth trying to figure out where I dropped this bag of RJ45 terminals. And of course, it's the only bag of these that I have. It fell out of my pocket at some point walking back and forth between my shop here and the barn. But found them. I have crimped on our end here for the barn side. I think we are ready to actually test this. And new toy out here. I'll be doing a video on this at some point in time in the future. It's not actually fully hooked up yet. But you guys have seen me try out a couple of these power stations here on the channel, and none of them have really been large enough to actually power the barn. This barn is not connected to the house. There's nothing running from the barn to the house for power. I ultimately want to put solar panels on the roof of this building, but the first step was having a power box that was actually big enough to power the barn. And we tested a smaller one from EcoFlow in the past, and I mentioned that I was going to reach out to them and see if they were interested in providing something for up here in the barn for a solar install. And they've sent this. I'm not ready to do the solar yet because it is like 20 degrees outside here, so that is going to be a little bit later in the year. But I did cart it up here and plug it in, and it's powering the lights up here now. And so far, it seems pretty amazing. This is a 240 volt unit and should have plenty of power to run everything up here for like a full day. So you'll see more of this on the channel in the future, but for now, that is what's actually powering this end of this Wi-Fi bridge and the laptop here. So let me get you guys back on the tripod. I'm gonna plug everything in and let's see if this works. All right, so this is supposed to be really easy to set up. The other end is already plugged into my network switch in the garage, and the cable goes through the little PoE injector that they give you. So this is the cable that goes up to the bridge unit that we have on the outside of the barn. And I'm going to plug this end into the one that says PoE. We'll plug just a short patch cable here into the side that says LAN. And I'll probably put a switch out here at some point in time, but for now we're just going to plug it right into this laptop and see if it works. So I don't know how long it's going to take to connect. I did test this out in the garage. Of course, the units were right next to each other, so it worked fine. And it took probably about a minute to pair up. And we'll just ping my router gateway. It's already working. I mean, that was less than 30 seconds. Maybe they did pair that one time, so maybe they kind of communicated with each other what channels they wanted to work on already. And it's saying 1 millisecond for latency, which is pretty good. Let me get you guys down closer so you can see the screen here. All right, I did see a couple pass by here, 36, 37 milliseconds. The majority of them are under 5 milliseconds, which is pretty good. I mean, we're not that far away either. It's just, I don't know how susceptible this is going to be to other Wi-Fi interference. Now the interfaces, this unit claims 300 megabits per second, but the interfaces are only 100 megs per second. So let's see what we actually get. All right, looks like it's averaging 81 megabits per second. That's not bad. It's not the full 100 megabits per second of the interface, which we wouldn't get that anyway. There's some overhead. We'd probably get at least high 80s, low 90s. So that looks to be pretty good. Let's run it one more time. All right, we get 77 megabits per second that time. So I do think we are limited by the Wi-Fi transfer speed between these bridge units. I don't think we're limited by that 100 megabit per second interface on the unit itself. but that's still not bad. I mean, ultimately, I'd like to be able to run 2 security cameras up here. And I'll probably put a Wi-Fi access point in as well, just so when I'm up here in the barn, I do actually have access on my phone, because the barn being steel, as soon as I come in here, I have no signal on my phone, no cell signal or no Wi-Fi signal. So it would be nice to have Wi-Fi in here at some point as well. But yeah, I think that's working well. Well guys, if you're disappointed in how the final design for today's video went, yeah, me too. I'm honestly wishing I had just stuck with the original design here. This one is, you know, in hindsight, it's honestly perfectly flexible. We should have just printed the whole thing in PETG. I mean, if this is this flexible in PLA and hasn't managed to break yet, I mean, I could break this. Let's see how much force it takes. Yeah, so I think I flexed that probably 2 to 3x in this direction as far as we can flex it in this direction with the backstop. So even PLA would have been fine for our final version. And PETG, I think, would have been the right choice. So I may just go ahead and reprint those final versions of both of those in PETG. And one of the reasons I didn't do it in PETG is because I wanted to use this dark gray. I felt like this was going to be the right color for both sides that we were installing this on. And I only have the PETG in, I think, black. And black would not be my first choice for, at least for this project. So I'm going to order a roll of probably the PETG HF in the dark gray if they have it in dark gray. If not, I'll just do it in like the normal gray color. And I'll probably just reprint the same final design, but instead of changing the material in the slicer to be the TPU for AMS for this upper part, I'll just print the whole thing as PETG. So yeah, unless you have a specific purpose for this TPU for AMS, I wouldn't recommend it. I think it does have its place. I'm glad it exists, and I'm sure I'll probably use the rest of this roll for something else. I think it would make good, like, just sort of soft-ish feet, because this stuff is also not anywhere near as flexible. It's still pretty hard. I would say this is closer to a PETG or a PLA than it is to TPU. But I think it would still make a better surface than a hard PLA or PETG, like if you're trying to seal 2 surfaces together. And, you know, I guess for softer feet, particularly for something heavy, I think it's probably going to have some give to it in comparison to just doing the feet in hard plastic. So I'll save it. It'll get used for that. The other thing that I got in that order, I didn't even open this yet, is I tried to get this TPU for AMS and one of these plates when they first came out, and they were sold out for a long time. You guys probably have one of these, and I'm just finally getting one now. This is the Bamboo Cool Plate, the Super Tack. So I'm looking forward to trying this as well. I don't think we've done too many prints where adhesion has really been an issue, but seeing the pictures that people have posted of the crazy angles that they're doing with like prints, like a tiny footprint, and the whole print's coming up at like a crazy angle and it's still sticking. I thought it was worth picking one of these up. So hopefully this is not the dud that this TPU for AMS was. I'm really curious to hear down in the comments if you guys have tried this stuff and had more success than I have. I dried this overnight at the recommended temperature, and I printed it at both the recommended temperature and a higher temperature that was recommended. And it might have been a little bit better at that higher temp, but still nowhere near the performance that I'm used to with TPU. And let me know down in the comments as well if you've tried one of these Super Tack plates. I am looking forward to trying this guy. Well guys, as always, thanks for hanging out here in the shop with me and out in the yard as well, even in that 20-degree weather, for this week's design and print. And if this is by chance your first time here on the channel, this is all we do. It's all functional prints. It's all stuff like this. A lot of stuff here in the shop, some stuff outside as well, a couple things around the house. So if you're into that sort of thing, check out some of the other videos on the channel. And if you like what you see, hit that subscribe button. Guys, if you do, I'll see you next Friday.